Okay, so this is Algebra 1, 7.7. This is geometric sequences. So, a geometric sequence, guys, is what?
Something that is in a geometric order.
Geometric order. How about it's a sequence?
Those 1, 2, 3, 4, 5.
No, sequence that goes, well, what's I say, has a common ratio. So a common ratio means that to get to the next number, you're multiplying it by something. So, multiplying to get next number. When I say common ratio, it means a fraction. So the next number could be by 2. So if I go by 2's, it might start at 2, and the next one would be 4, and then it'd go to 8, and then it goes to 16, right? 2, 4, 8, 16, 32, dot, dot, dot. That's a geometric sequence. Why? Because it's going up by a factor of 2. Now remember, technically by now we already did arithmetic sequences. And arithmetic sequences go up by adding or subtracting. Or up or down by adding or subtracting. So this is geometric. This is arithmetic. 2, 4, 6, 8, 10. Because I'm adding 2 every time. Okay? So you're going to be asked. You're going to be looking at a sequence and say, is this geometric? Or is this arithmetic? Or is it neither? So, an example of 1, 3, 6, 9 is a what? What kind of sequence? It's going up by 3's. This, guys, how we do this and say it's 3 minus 1. 6 minus 3. Actually, that shouldn't be. That should be a 0, right? Sorry. Did that make it better?
Yeah.
What's 3 minus 0?
3.
It's 3. What's 6 minus 3?
3.
What's 9 minus 6?
3.
This is called a common difference. This is arithmetic. That's the adding or subtracting one. If I was to have something like, let's see, 125, comma, 25, comma, 5, comma, 1. This is going down by a factor of what? 5's. But not subtracting 5's, but by dividing. And so, this means I would take the second number over the first number. The second number over the first number. The second number over the first number. And 125 over 125, 5 over 25, and 1 over 5 are all the same fraction of. They have the same ratio. That ratio happens to be 1 over 5. They all reduce to 1 over 5, right? So therefore, this is a common ratio. And this would be geometric. It's geometric sequence. So the first part of your homework is just determining, is it geometric or is it arithmetic? Are you adding or subtracting or multiplying or dividing? That's the question. Now what we're going to do is find the nth term of a geometric sequence. This is called the explicit formula. And if I want to find the nth term, or a sub n, any term of the sequence, it would just be a sub 1 times r to the n minus 1. N is the term we're looking for. R is the common ratio, and a sub 1 is the number of the first term. So this is first term. First term. Term n. N term. And R is the common ratio. So if you're given those things, we're going to be perfectly fine. Or if you're given a sequence, you're going to be fine. So let's go back to the sequence of 2, 4, 8, 16, ... I want to know what's the 20th term. 20th term, which would be a sub 20. That's what I'm looking for. I'm looking for a sub 20, the 20th term. Now, a sub 2, or a sub 1, sorry, or the first term is here. This is a1, right? Then it's a2. Then it's a sub 3, a sub 4. I'm missing a whole bunch. What I could do is do a5, a6, right? And keep going on itself until I got to the 20th term. Does anybody really want to do that?
No.
No. There's got to be a better way. And so the better way, guys, is to say, hey, can I find the common ratio? Do I know the first term? I know the first term. That's here. So I know this part. I know n. N is going to be what? N will be the 20 because I'm looking for the 20th term. So if I can find R, I'll have a formula that I can use. What is the common ratio? What is this?
2.
Yeah, it's 4 over 2, 8 over 4, 16 over 8, which is 2, which is R. The common ratio is a 2. So, very generically, a sub n would be 2 times 2 to the n minus 1. That's your formula. That formula now will let me find any term I want, whether it's the 20th term, the 5,000th term. All I need to do then is go a sub 20 is 2 times 2 to the 20 minus 1. Wait a minute, 20 minus 1 is what? What's 20 minus 1?
19.
19. Take your calculator out. 2 to the 19th power times 2. No, that's not 20. That should be 2 to the 19th. 2 to the 19th power times 2. It's a big number. We get what?
104,000.
104,000? 104?
104,8576.
76. So that's definitely not a comma there. 0, what is it? 1048. So 1,048,576. That's a pretty large number. And all it was doing is just multiplying by 2, going up by 2's. Right? Multiplying by 2, not going up by 2's, but multiplying by 2. That's how you're going to find your ratios. That's how you're going to find your values.